Okay, so let's move on to chapter 10. So in chapter 9, we talked about what? We talked about tests, right? We did the significance testing, where in chapter 8, we did the confidence intervals, right? So chapter 8, we did confidence intervals, and we did confidence intervals, we did the basics, and then we did the confidence intervals for proportion, then we did the confidence interval for a mean. And then in chapter 9, we did the basics of a significance testing, and then we did the significance testing for a proportion, and we did significance testing for a mean. Okay. So in chapter 10, we're now going to compare two proportions. That's what we're doing in chapter 10.1, and in 10.2, we're going to compare two means. And then in 10.3, we're going to do something that's called paired testing. Is it called? Yeah, paired data. We're going to do paired data. Okay, we're going to do paired data. So that's the big picture-wise we're going to do in chapter 10. So for chapter 10.1, we're going to compare two proportions. In 10.2, we're going to compare two means. 10.3, we're going to talk about something that's called paired data. Okay, all right, so here we go. Let's do 10.1. 10.1, we're going to do comparing two proportions. Okay, let's go ahead, and we can't do this in class. Let's kind of go ahead and read the activity. It says on page 619, there's an activity called Who Likes Tattoos? So I want everybody to read to themselves what it says there, and then you will recognize this because we talked about this. We talked about this when we were doing bias, when we talked about bias and surveying bias. How can bias be introduced? Okay, so let's go ahead and read that. So once you're done with page 619, that's all I need you to read, really. So are you good with that? Everybody understand that this was the tank top, right? This was the tattoo. So one time the surveyor is going to show her tattoos and ask them if they are okay with tattoos. And then the other one's going to be, she's going to be in long sleeve and ask the same question and see if that introduced bias, right? Okay, any response bias there. Okay, so you flip the page, go to 620. It shows you that when we surveyed 30 people with a tank top and the tattoos were visible, and they asked them whether or not they liked tattoos. There was 18 to 12, yes to no. And then when she was in long sleeves, it was the complete opposite. It was 14 and 16. So 14 yes, 16 no. Okay. So the question is this truly response bias, or could this just happen by happenstance? Could it just be you got an unlucky draw, right? How is that, that's what, so is there truly bias or not? So this would be the question that we're trying to answer here. Okay, so on page 620, it says the difference in the proportions are 18 over 30 minus 14 over 30 for a difference of 0.113, right, which is 4 over 30, right? So that's a difference there, okay? So does this difference provide convincing evidence that the appearance of the interviewer has an effect on the response? Okay, so that's what we're trying to do. We're comparing the two proportions, okay? So we have a population here. We did one SRS of 30 people, and we did another SRS, and we got where we had, again, n is equal to 30, but the p hat here was 18 over 30 versus the p hat here was 14 over 30, right? Whether you were in a tank top or you were wearing long sleeve, right? So the question is that does the tank top actually have make a difference, or is it just, bad luck? Okay, so that's what we're trying to answer here. Okay, so if you look at there, it says in this activity, so if it was just by happenstance, that means it doesn't really matter whether you're wearing this or not, right? So we're going to go ahead, and if you look at it, the way they construct this experiment is that you're going to say, since out of the 60, right, we had 32 yeses and 28 nos, we're just going to go ahead and shuffle up a deck of 60 3x5 cards, and 32 we're going to write yes, 28 we're going to write no, and we're going to just do a random sample, because I can just pick wherever I want and go ahead and see what's going on, right? Because that's how I can what? I'm actually going to simulate this, right? I'm simulating this, right? So if I do that, so let's see what happens. Okay. So number one, it says using 60 index cards, write 32 yes, 28 no. And then number two, so we're going to do a simple random sample for 30 for each one of them, right? So we're going to do 30, take out 30, and then we're going to calculate the difference in the proportions of yes and no. Teacher will draw and label. Okay, so we're going to do this, okay? So this is what we're doing. So we want to find what's happening here, okay? So this is where we're actually comparing the two proportions. Same population, two different simple random samples, right? Okay, so let's go to 10.1. And let's go to 10.1 and on page 621, sampling distribution of a difference between two proportions, okay? So if you go there, blah, 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 this one is here. Okay, so on page 621, bottom, to explore the sampling distribution of P1 minus P hat 1 minus P hat 2, let's start with two populations having a known proportion of successes. Okay, suppose there are two large high schools, each with more than 2,000 students in a certain town. School 1, 70% of the students did their homework last night, and only 50% in school 2 did their homework at last night. The counselor at school 1 selects a simple random sample of 100, records a proportion. There's the sample number 2. In school number 2, they select 200 students and do that, okay? So we can say that the difference, what can we say about the difference in proportions? So we have now, we're gonna have two different populations. So I have population of school number 1, population of school number 2. They were both greater than 2,000. I did a simple random sample here of n equals 100 from a p was equal to 0.7 here. P was equal to 0.5, and I did a simple random sample of n equals to 200 here. Okay, so this is where we're at. Okay, so let's take a look at what we know here. So I know what from here, this is less than 10% because they're greater than 2,000. These are both less than 10%. Okay, so I'm satisfying that. I'm satisfying that. It was a simple random sample. We already know that. Okay, so what would your P1 hat? We have P2 hat. This is P1, P2 here. Okay. So what do we know here? What do we think the P1 hat is going to be? Do I satisfy the large counts here? Simple random sample, less than 10%. The NP1 is equal to what? N was 100 times P1 was 0.7, right? And N1 minus P1 is going to be equal to 100 times 0.3. 70 and 30, they are both greater than 10. So we satisfied the large counts for this guy. What about this guy here? I have NP2 is going to be equal to 200 times 0.5, and N1 minus P2 is going to be equal to 200 times 0.5, 100, 100. They're both greater than or equal to 10. Again, the large counts work here, large counts work here. Simple random sample, they both satisfy that. So we're going to say that this is a normal distribution, correct? So we're going to conclude that in P1, we're going to have a normal distribution with P1 hat being 0.7 because it's an unbiased estimator, with a sigma of square root of 0.7 times 0.3 divided by n, which is 100. So that would be sigma 1. Then over here on the bottom one, we're going to do the same thing. It's going to be a normal distribution with P2 hat being 0.5 and sigma 2 being square root of 0.5. 1 minus 0.5 is 0.5 over 200, right? And I can calculate these, and the first one will be 0.05458, 0.0458. And the other one was going to be 0.0354, 0.0354. Okay, this is stuff that we've already done before. We've done all this. Okay, all right. And blah, blah, blah. And I'm saying, okay, we're all good, we're all good. So what do we know about, what can we say, again, about P1 hat minus P2 hat? Okay, so that's the question of the day, right? What can we know, can we say about P1 hat and P minus P2 hat? So let's talk about P1 hat minus P2 hat. Okay, what do you expect that to be? The difference is going to be this guy minus this guy. So you expect that to be 0.2, correct? You expect that to be 0.2. And if you remember correctly, the sigma of differences was what? Isn't this the square root of sigma p hat 1 squared, sigma p2 hat squared? You guys remember this? In other words, if I square both sides, I get this squared is this squared plus this squared. So the standard deviation of the difference of the proportions is going to be the variance. So I mean, this squared is what? It's a variance, correct? Isn't that the variance? Standard deviation squared is the variance. So the variance of P1 hat minus P2 hat is the variance of P1 plus the variance of P2. Okay. So we've seen this before. Okay, so this is basically it. So if you go to page 623, there's a green box there that says you choose a simple random sample size of N1 from population there and N2 from population 2. The sampling distribution of P1 minus P2 is approximately normal if the large counts are met. And okay, and the mean of the sampling distribution is going to be the difference here, P1 minus P2, okay, and the sigma is this squared plus this squared, right? That's what it says. Okay, so let's flip the page. Let's look at the yummy goldfish example. So let's flip the page, go to page 624. Now, on the top part of page 624, it graphically shows you what it's meaning, right? The mean of P1 minus P2, that's the mean, and the standard deviation is this guy right here, right? So again, if you were to do this, it would be the same thing over here. You would have what? Square root of this guy, which was this guy, 0.458 squared plus 0.0354 squared. This is 0.04, I'm assuming. think I'm missing a 0 there. Okay, so this is how you would do it. Okay. So let's go to that example there. Let's go to the example of the yummy goldfish. Your teacher brings 2 bags of colored goldfish crackers to class. Bag 1 has 25% red, bag 2 has 35% red crackers. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a simple random sample of 40 from bag 2. Let P1 hat minus P2 hat be the difference in the sample proportions of the red crackers. Okay, so let's go ahead and kind of write this down before we go any further. Okay, so we have bag 1 is 25%, and bag 1, P1 is equal to 25%. Bag 2 is 0.35. We're going to take a random sample here where n equals 50. I'm going to take a random sample here of n equals 40. Okay, and what else do I need to know? Okay, we're good. A, what is the shape of the sampling distribution of P1 hat minus P2 hat? So P1 hat minus P2 hat is going to be equal to 0.25 minus 0.35, negative 0.1. That's going to be the mean, right? The standard deviation of P1 hat minus P2 hat is going to be equal to 0.25 times 0.75 over n, which is 50, plus 0.35 times 0.65 over 40, right? Because the standard deviation of P1 is this guy of the square root of this guy here, but I have to square that. So that's why there's no square root there, because I squared it. And same thing over here. Okay, if I calculate this, where am I looking over here? I'm going to get 0.0971. Okay, so it's normally distributed with this as its mean, this as its standard deviation. Okay, B. Oh, the shape is a normal distribution, okay, because it meets all the, meets all the conditions, right? NP, N times 1 minus P is 0.75. They're both greater than 10. Same thing here, 40 times that is going to be, what, 14, so greater than 10. So, and 40 times 0.65 is going to be 26. So it's going to be greater than 10. So the large counts are met for both of them. By the way, you have to check for both of them, right? So the large counts for, I check for large counts of both of these, they work. Both of these is a simple random sample, so we're good. And both of them are less than 10% because they are each have 1,000, was it? Does it say? Yeah, 1,000, more than 1,000 crackers. So the N, the large N was greater than 1,000. So therefore, yeah, it's going to satisfy the less than 10% rule also. Okay. B, find the mean. The mean is right here, negative 0.1, and the standard deviation is this guy right here. Calculate and interpret the standard deviation of the sampling. So if you want to interpret this, it would be what? The difference in the sampling proportions of the goldfish crackers are typically vary by this much from the mean of this guy right here. Okay. All right, we'll stop right here and we'll start working on that first homework.